Hello guys, so in this video what we are going to see is one very cool knowledge assistant which I created to retrieve documents from my Google Drive and create an easy way to chat using those Google documents using RAG. So in this video we are going to see its end-to-end demo along with its implementation and what optimization techniques I have used to optimize the process of retrieving documents and make sure it almost always retrieves the correct information based on the documents that you have provided. So let's start with the demo first. So Knowledge Assistant is the name of the application, an internal RAG tool designed to help index your Google Drive documents and chat with it using OpenAI powerful language model. So created one agent behind the scenes to basically chat with your document. So right now on other screen, I'm just authenticating using my Gmail ID. So it would ask you for some authentications to proceed. So I would just continue with that. So basically it would ask you for your email ID, username, and also Google Drive folder access to make it work. So as soon as you log in, you would be able to see something like this. And I have already configured my OpenAI key. So here in this part, you will have to put in your OpenAI key for make this application work. And second part is the Google Drive part, where you have to first give the authorization to this app to access your Google Drive files so that you can select any folder of your choice. So here I'll be selecting one of the document called knowledge base and proceed with that. Once the folder is selected, you have to click on connect Google Drive. So what it will internally do, it will retrieve all documents from this particular Google Drive folder and enable RAG system to first create embeddings out of those documents, create a vector store so that you can later chat with these documents. So let me open Google Drive folder from where I would be retrieving all the documents. So I've given these particular files, the knowledge base files, which contains like different stock information. So I have created the sample document just for experimenting with the RAG system. So here are some financial report, pros and cons, and some future performance related data of 10 stocks. So this is the sample data which I have created. So once the indexing is complete, as we can see here, it is able to find all 10 files inside this Google Drive folder. And once all the configuration and everything is completed, we can go to the chat folder to now start chatting. So let me start by saying hi. So in this particular case, it returned, hey there, how's it going? So internally, I've implemented a way where it route queries to a agent, which is actually required for the request. In this case, the RAG agent was not required because simple queries like hi, hello should not be routed towards a costly agent. Now, let me list some documents, or let me list all documents. Internally, it is going to the LLM agent, which is residing in the backend and coming back with the response and also some sources where it retrieves that information. So as you can see here, it has retrieved all the documents which I have, and it is also providing the document sources. So if I click on this, it is redirecting me to the file which is stored in my Google Drive. So we have created the sources list because it is very important for LLM agent to not hallucinate and always provide data from the actual sources. So let me compare two of the stocks now to see how it performs and how is it able to connect with different documents and extract some information out of it. So it is processing now, and now it has given me some analysis. It has given me financial performance along with growth prospects with pros and cons. So basically the RAG system is working very efficiently without any errors and in a way where it is not answering anything which is outside its knowledge. So that also can be tested. Let me ask about Zepto, for example. So ideally it should say that this information is not inside its database, so it's not returning any response. So that is like the ideal and correct behavior that we should expect out of any agent. Now let me go through the code base of this project to show you guys how I have implemented the complete thing. So this is the README file. So these are some architectural components. So UI, I'm using normal JavaScript for that. So it is a modern chat interface with glass morphism and real-time feedback. In the backend, I'm using Flask Python API for making this thing work. And for front-end, normal HTML, CSS, JavaScript. For RAG implementation, one framework which I used is LlamaIndex, along with some internal optimization techniques, which we will be talking about in detail. And then the database where I'm storing the user information and all. Just to prevent over-engineering, I use some of the self-managed services that are there, pre-managed services that are already there on cloud. So for databases, I used Firestore from Google. And for vector store, which is storing the embeddings of all the documents, I use Zilliz Cloud. So I found this free cloud tool which has very generous offering. So I just relied on that to store all the embeddings and all. For chat model, we are relying on GPT-4o Mini. And then comes the knowledge base. So right now our knowledge base is Google Drive, but in future we can have anything as the knowledge base, whether it be on Notion doc, maybe local folder or anything else. But right now in this case, we have a Google Drive connector which retrieves your document and acts as a knowledge base. Then we have some analytics included. So that is Langsmith, which I am generally using for LLM tracing and to see how many input tokens and output tokens I'm using. Now coming to the workflow, so it is pretty straightforward and simple. User comes to our platform, get the authentication done using Google sign-in. Internally, it is using Firebase Auth for doing that. Now comes the configuration part. User has to enter their OpenAPI key. They have to select their Google Drive folder for making the documents indexed properly, for making the RAG pipeline work. After that comes the chatting part, where first user asks a question, and then there is like a router sitting behind the scenes, which generally routes your simple casual queries such as hi, hello to a direct LLM response, where I'm directly sending this thing to LLM and it is retrieving the output and which I'm showing as answer. But if user is asking something which is related to the documents that were retrieved from the Google Drive folder, so it is going towards this pipeline. So there is like a hybrid retrieval mechanism. Again, we're going to talk about that with re-ranking and synthesize mechanism, and that thing is given as answer to the chat reply with citation. So citation is also a very important thing. So we are giving the sources from where we have like retrieved all the answers from, which is very important again. So also like written it in text format. Some of the key features that we can see here, we have Google Drive integration which seamlessly connect with your Google Drive folders, index documents, and you can then chat with your documents seamlessly. Then comes a scalable multi-tenancy architecture. So we are using Zilliz Cloud again as a vector store with all the user metadata and other metadata for making sure it is multi-tenant. Different users can come together, store their data, and make sure no user data is shared among each other using metadata filters. Then comes the hybrid retrieval engine that combines vector search for semantic meaning and BM25 search algorithm for exact keyword matching to improve the accurate context that is required by the LLM. So that is basically improving the way how the RAG pipeline is working. Then we have observability using Langsmith, and then some automated synchronization. So some backend schedulers are working automated in an automated way to always retrieve the latest documents from your Google Drive and keep the knowledge base up to date. And it has some advanced techniques implemented, which using checksum, which automatically checks if any document has been updated in your Google Drive. If not, no need to reindex and save your resources. Some of the future plans that are not implemented yet are as written over here. API gateway rate limited for improving the architecture, feedback, storage, analysis, and analytics with advanced evaluation metrics. So right now I haven't implemented this. In retrieval and access, we can also implement per user ACL filtering. For example, if some Google documents have some particular user access rights, we can also like filter on based of that to see who all user can access what all documents. Right now it's pretty straightforward. For example, if there are 5 users, they attach their 5 Google Drive documents and they are only able to use those documents without sharing it with someone else. Then comes about the LLM safety. So we have not implemented the context history compression or caching techniques, which again can improve the LLM performance and the latency part. And then there are like some other LLM optimizations such as context window management, usage dashboard, and alerting system if LLM usage spikes up. So all of these haven't implemented as of now. Then comes the installation and setup part, which is very straightforward and simple. So we have to set up like .env file. We have to set up a Python environment using conda. Requirement.txt is given over here. And rest of the process is to deploy on GCP. So I'm using Google Cloud to set it up all on Google Cloud. So there are like some steps which are mentioned to set it up. So I won't go through it since it's like straightforward and simple. So anyone can come here in the README and read about that. Now coming to the RAG pipeline, which is like very important. Let me open the preview mode. So overall, what is happening as soon as user types in some message, the API, which is API slash chat slash message gets invoked, and it takes in like it creates like a query bundle, which is then sent to the RAG pipeline. So RAG pipeline, again, as discussed, it routes the request between casual chit chat LLM versus the uh, RAG based agent. So based on the query, it automatically decides that. And retrieval engine, which is running behind the scenes, is for pulling the Google Drive documents, chunking them, and doing hybrid retrieval. So again, coming to the retrieval pipeline. So this is the Google Drive where we first chunk and embed the documents to store it into the vector store, which is Zilliz in our case. And as soon as user queries the system, it retrieves all the data from the vector store based on the relevance. Again, using the hybrid retrieval technique, which is vector retrieval plus BM25. And once the data is retrieved, so LLM re-ranks the data. So for example, we have implemented top tier ranking where it gives you, let's say, 5 results. So there's a LLM sitting on top of that which re-ranks system based on the query that user is asking for, and to make sure the best answer is delivered to the end user. This is the query routing that we have already talked about, and these are the optimization that are like implemented in this repository. Hybrid retrieval we have talked about. Re-ranking with LLM improves the relevance of the retrieved chunks. List specific prompt, dedicated prompt templates are created here, so to make sure LLM performs in best way and only gives out the information which is required by the end user. Adaptive retrieval depth, so we have implemented top key and max result, and with like higher number for better retrieval quality. Document catalog feedback, so internally we are also like building a catalog of all the documents for making sure if user is asking for any particular document or listing any document, we are able to use this catalog for creating the answer. So talking about the LLM agent, so we are using GPT-4o mini in this case with the text embedding as text embedding 3 small, which is a particular type of embedding offered by OpenAI, and telemetry is Langsmith. So yeah, I think that is about the repository. Let me also quickly see if I can go through some files. So this is normal backend architecture. We have like Docker files for backend created and Docker compose file again for the complete setup, as we see over here. So this is basically running the gunicorn for the Flask service. Logging is implemented to save logs into the files. Here we see some services. We have the schedulers, Langsmith, tracing implemented, the way to include the Firebase Google authentication, and then we have like some safety implemented. Now, if we come inside the RAG folder, so this is the main folder where we have implemented all the way of optimization, retrieval, and indexing, all of that. So this is rag.py as the main file where we have all the RAG service to get the vector store, implementing the catalog and resetting cache and initializing index. So all of these things are implemented over here. Then we have two query engine. One is casual for normal chit chat, and then other one is lazy RAG query engine, which is for document search, retrieval, and then making user able to chat with the documents. Routes is normal, so we have normal 2 page in the front end. One is config, another one is chat. So that was backend. Now coming to front end, we have like some static file, JavaScript, image, and CSS. So these are straightforward and simple, nothing to take a look at and talk about. And these are the README requirement file is with all the dependencies that we are using for this document. And then there is cloud build YAML file, which is for cloud deployment on GCP, making the building part of the container and deploying part easier. Yes, so I think this is the overall application that we have built to configure our Google Drive folder and easily chat with that. So this application is already hosted on a production URL, so anyone can go and chat with it. And also I would be providing the GitHub link on my website, which is arjundaprogrammer.com. So anyone can go there and access all the projects that I keep revealing and uploading on my website. Thank you.